Good afternoon, everybody, and a warm word of welcome to all of you here at our first Geography Telematics broadcast. I'm Glenn Samai, and I will be responsible for the geography lessons for this year. Now, today we are going to have a look at climatology. Now, I know that most of you have not completed the whole climate and weather syllabus, but I would suggest that if we do work that you have not done in class yet, please pay attention, because I can assure you that it's going to just help you and make it easier to understand the work in the near future when your teacher will present it to you. So without further ado, we are going to have a look at climate and weather, as I've said. Obviously, I won't be able to do everything in the syllabus, but I will have a look at the most important work, and also very popular work that's usually examined at the end of the year and during, of course, your other assessment pieces throughout the year. Now, I will also have a look at exam questions of last year, especially questions where students had a problem answering the questions. Okay, so let's have a look at our climate and weather. And the first thing that I am going to present to you will be mid-latitude cyclones. And as I said, I won't be able to do everything, but these are the most important things that you must know when it comes to mid-latitude cyclones. You must firstly know what are cold and warm fronts. That's very important. You must know the characteristics of the mid-latitude cyclone. You must know the stages, and you must also know the weather associated with mid-latitude cyclones. All of those four things are very, very, very important when it comes to for examination purposes. Now, okay, as I've said, is that before you really want to understand your mid-latitude cyclone, you must know what is a cold front and what is a warm front. Now, let's have a look at the difference between the two. Firstly, in the exams, when we ask, sometimes you get the question, define a cold front, define a warm front, then too many of you still make the mistake by saying a cold front is cold, or cold air is found there, and a warm front is warm, or warm air is found there. Please, people, make sure that you know your definitions. Very, very, very important. In fact, both air masses, warm and cold, are found by each of these fronts. So let's just have a look at our cold fronts and our warm fronts. Okay, our cold front, on the one hand, very important. If you want to know the difference between the fronts, you look at the type of air behind the front. Have a look at this. Here we've got the cold front. Here we've got the warm front. But remember what I've said. Look at the type of air behind the front. Here's the cold air front. Behind the cold front, we've got cold air. Can you see that cold air is moving towards the warm air? Okay, and this is the symbol of course, of your cold front. Let's have a look at the temperatures. Look in front of the cold front, 27, 24, 28 degrees Celsius. Just look at the back. Behind the cold front, 18, 14, 16 degrees Celsius. In other words, take note that you always have your cold air behind the cold front. Very important. Exactly the same when we have a look at our warm front. Here we've got the warm front. What did we say? You must look at the air behind the front. This air is moving in this direction. Here I've got the warm air, the cold air. The warm air is behind the warm front. Let's have a look at this. Here we've got the warm front symbol. Have a look at the air in front, 19, 20, 17 degrees. Let's have a look at the air behind the front, 26, 24, 28 degrees Celsius. So people, please, you must remember, when people ask you, when you've asked in the exams to define what is a cold front, what is a warm front, please, people, we don't want the answer, a cold front is cold and warm front is warm. Remember, you must look at the type of air behind the front. Okay, in the cold front, you've got cold air behind. What happens is cold air moves towards the warm air, and the warm front, exactly the same actually, but the opposite air behind, which means the warm air behind moving towards the cold air. Okay, so this would be our warm and cold fronts. And as I said, people, you must understand this if you want to understand the mid-latitude cyclone. Now, the characteristics of the mid-latitude cyclone is very, very important. You know that this diagram that I'm going to show you now, that I'm going to discuss with you now, it's so very, very important, because most of the questions based on mid-latitude cyclones, the answers come actually from this diagram, because here you've got all the characteristics, and all you've got to do in a question, exam question paper question, you've just got to put all these characteristics together, and you'll see how easy your mid-latitude cyclone actually becomes. Okay, let's have a look at the characteristics. The first thing that you must know is this is the isobars, these lines here. The second thing that you must know, a low pressure. A low pressure at the mid-latitude cyclone. Another characteristics, this is our cold front, and that is the warm front. Have a look at the symbol here. Please, people, don't get mixed up with the symbols of the cold and the warm front. You must know where's the cold front, where's the warm front. You must also know the clockwise wind circulation. Now, I just want to have a look at this clockwise wind circulation. Remember that this mid-latitude cyclone that I'm dealing with now is in the southern hemisphere. All right? So we've got this clockwise wind circulation. In fact, all low pressure systems have this clockwise wind circulation in the southern hemisphere. Okay, so that is your clockwise wind circulation. Let's go further. This would be the warm sector that we've got here, and here we've got the cold sector. Now, let us have a look at all this, the warm front and the cold front again. Remember what we said. When we opened this broadcast, we had to look at the cold front and the warm front. Have a look at this. Here we've got our cold front, here we've got the warm front. How do I know this is a cold front? If you remember, we said that behind the cold front, we usually have our cold air. Can you see this blue here? Behind the cold front. In the front, we've got the warm air. So this is the reason why this is a cold front, because we've got cold air behind the front. You see how these things come back again to that first diagram that we've had. Have a look at the warm front here. Here we've got the warm front. Cold air here in front. Warm behind. Look at this. Warm front, warm air behind, moving towards the cold air. So please, Matrix, don't get mixed up. When you have a look at this, what you should do actually is to take this diagram and draw it over and over and over until you really understand and get these labels, to know these labels for with regard to the mid-latitude cyclone. Okay, so these are the characteristics of the mid-latitude cyclone. The following thing that I'm going to have a look at is the development of the mid-latitude cyclone. Now, you must know that when we have the mid-latitude cyclone, we have basically four stages of development. The initial stage, the development stage, the mature stage, as well as the occlusion stage. These are the four stages, and you must be in a position to describe each of these stages. A very popular question is that they will give you a synoptic weather map, and they will ask you in which stage each of these mid-latitude cyclones are. Now, in this case, it's quite easy because, of course, this would be our development stage that we've got here. Can you see them? This one will be our mature stage, and, of course, that one will be the occlusion stage. You must be able to put the stages in the correct order, and you must be able to describe the characteristics of each of these stages. Very, very, very important that you must be in a position to do that. Now, when you have a few cyclones in the same area, more or less in the same area, it's called a family of cyclones. Of course, you have a look at family. Three of them, each one different ages, just as your family there at home. So this is called the family of your cyclones. Okay, now this question appeared in last year's examination, and students had lots of problems answering this question. It's a very important question. It's a paragraph type question. Now, Matrix, let me just speak very quickly about paragraph type questions. Please, people, you know, the paragraph type questions are sometimes very, very poorly answered in the exams. The reasons, therefore, is that you don't practice to write your paragraph type questions. So during the course of this year, when we visit you, have a look at the way in which we answer the paragraph type questions, and please look at them, study them, and try to write them. But first, and most importantly, you must know how to read them. So let's have a look at this one. This one appeared in last year's exam, and as you see, it's basically a direct question. Write a paragraph in which you explain the development of a cold front occlusion. Now, if they ask you to write a paragraph in which you explain the development of a cold front occlusion, then it means that you must know that the occlusion follows the mature stage. So in other words, what they are actually asking you is to describe this stage as it moves over towards that stage. You must explain the development of the occlusion. Now, here we've got the mature stage. Now, this is what your answer should have looked like. In the mature stage, the air behind the cold front is cold. We've heard about that, am I right? Here we've got the cold air, here we've got the warm air, and the cold air is moving towards the warm air. Now, what's very important is that you must know that the cold air is moving much faster than the warm air. And as it moves much faster, it drags this cold front along, and what happens is this cold front starts to catch, it moves closer and closer and closer towards the warm front, and eventually it catches up with this warm front, right? And then this is the stage that you get here. You see the cold front started to move towards the warm front. It caught up with the warm front. And what happens then is that the cold front, the cold air of the cold front undercuts the warm front. And have a look at this diagram that we've got here. Here we've got the cold air. You see it undercut the warm air. And what happened is, look at the last fact there, the warm sector is lifted off the surface. Here's the warm air. And if you can remember the first diagram that we had, the warm air was on this side and the cold air was on this side. But see what the cold air did. It moved towards the warm air, it catched up with the warm front, and what happened was, as the cold front undercut the warm front, it lifted up the air, and now you get all the warm air you get there in the atmosphere, upper atmosphere. What I want to like to show you is have a look at this diagram. They can also ask you to draw a diagram of a cold front occlusion. And please, Matrix, now early in the year, when you get the diagrams, please practice your diagrams. In fact, if you get a diagram, especially diagrams that are very simple, easy to draw, like these ones, for instance, whether it's a cold front, a warm front, or occlusion, these type of diagrams, you must be in a position to draw the stuff. In last year's and previous year's examination, too many candidates lost too many marks because they were not in a position to draw simple diagrams. So please remember, geography is about diagrams, right? You can explain things by means of diagrams. Make sure that you can draw your diagrams. Okay, so this was the mid-latitude cyclone. What's also very important of the mid-latitude cyclone is that you must know the weather changes that associated with the passing of a cold or a warm front. Remember, here's a cold front passing, or a warm front is passing over the area, and you must know what weather changes take place as these fronts move over the area. Let's have a look. Now, here we've got three weather stations that I've just put here, and you'll see now. You must look at the relationships between these three weather stations, and you must see how the weather changes as these fronts move over these weather stations. Okay, here we've got our warm front. Now have a look at this. What happens when a warm front moves over an area? Here we've got a weather station in front of the warm front, and here one behind. Now, this means that this warm front has already moved over this one, but not that one. Let's have a look. Have a look at this. Firstly, what happens to the temperature? By the way, people, if they ask you something about weather changes, it's very important whether it's your mid-latitude cyclone, your tropical cyclone, anything that deals with weather. You must know that when we deal with weather, you must say something about temperature, you must say something about air pressure, say something about wind, cloud cover, and rainfall. Right? Those are the five things or precipitation. Those are the 5 things that you must mention, because that is what weather is all about. So if somebody asks you anything with regard to weather changes, you must mention these 5 things. Let's have a look at them. Firstly, the temperature rises to the maximum. Have a look at here, 18, 24. Can you see after the warm front moves over, a rise in temperature? All right. Air pressure drops. The wind trend changes from northeast to northwest. Can you see that's the direction of the wind? Northeast, look at that. Northwest, all right. Cloud cover decreases. Here it's about 75% that we've got here. Here it's only a quarter. So your cloud cover decreases. And no rainfall. You can see the rainfall completely stops. But now, what happens when a cold front moves over the area? Now again, Matrix, remember you're 18 years old. So how many cold fronts have moved over an area in your life? Quite a few, okay, especially if you're from Western Cape. Now, you know what happens. In fact, if I ask you this question, you don't even need to study, you don't even need to look at your notes. You know what's going to happen. You know, firstly, the temperature is going to drop. You know that it's going to become cold, am I right? You know that what is going to happen. You know the cloud cover is going to increase. You know that. You know that as the cloud cover increases, it is going to rain. So these are things that you know what happens when a cold front moves over an area. So let's just have a look and check on all those stuff. Here we've got the cold front. What happens? Firstly, temperature drops. Have a look at that. 24, after the cold front moved over, 16 degrees. Immediately you would drop in temperature. Air pressure increases. The wind changes from northwest to southwest. Look at that. That's a northwesterly wind. This is a southwesterly wind. Very, very, very important. The cloud cover increases. Right. Cloud cover. Here we've got the quarter, and look at that, 100%. Okay. And then, of course, heavy rainfall. That heavy rainfall, absolutely no rain. Now, if you want to interpret these stuff, Matrix, you must know your symbols associated with your synoptic weather map. Otherwise, there was no ways that you would be able to see these weather changes that take place as these fronts move over. So please, people, when it comes to synoptic weather map, remember, it's not like your topographic map where you get the key. No key with your synoptic weather map. See that you know what every symbol stands for, what every one means. Please, people, it's going to make it much easier on yourself. Okay, so this would be our mid-latitude cyclones. I'm going to move over to tropical cyclones now. Now, the tropical cyclones, these are the things that you should know. Favorable conditions, characteristics, the location, the weather patterns, development stage, and how managed. That is very important. These are the things that you must know when you have a look, when you study your tropical cyclone. Okay, now have a look at this. Firstly, let's have a look at the characteristics. Now, this slide is a very, very important slide. This is one of the slides that I usually show over and over and over when I work and deal with Matrix. Very important, because all the characteristics you see here in front of you, and all you must do is you must know the characteristics and be able to apply it. Let's have a look at the characteristics of your tropical cyclone. The first thing that you must know, there where I've drawn the circle now, this is where they are born, or where tropical cyclones occur. Now, let's have a look. Firstly, you must see that the tropical cyclone occurs in the sea. That's the first thing. In the tropics firstly, and in the ocean. Okay, very important. That's why they call it a tropical cyclone. Yeah, I see I've got a question here. What is a mid-latitude cyclone? Now, please remember, we do two cyclones. The tropical cyclone and the mid-latitude cyclone, okay? Your mid-latitude cyclone is more in your mid-latitudes, around about here where we are. And the tropical cyclone, of course, as the name says, within the tropics. Okay, so we are looking now at the tropical cyclone. Right, so here we've got, where does it occur? Firstly, here, in the tropics, that's why it's called a tropical cyclone. In the ocean, and further than 5 degrees from the equator. Now, why further than 5 degrees from the equator? Because it needs Coriolis force. At the equator, last year in your grade 11, you should know the Coriolis force at the equator is 0, and as you move further, the Coriolis force picks up, and the tropical cyclone needs this Coriolis force. That's the deflection of winds. It needs it to set its spinning winds in motion. Okay, so that's the first thing you must know. Now we're looking at the movement. Now, have a look at this one. The tropical cyclones move from east to west. Remember that mid-latitude cyclones move from west to east. These ones from east to west. Here is moving. Have a look at the movement, and immediately you'll see the following thing. That this tropical cyclone is moving away from the equator, never towards the equator. Right, so here we're moving. In the eye of the tropical cyclone, no wind, no rain, and no clouds. Still moving. And now we're moving towards Madagascar, and now we're moving towards Africa. And as it moves to Africa, as it hits Africa, then it's going to destruct. The form of destruction that you've got there, storm winds, torrential rain, and flooding. These are the few ways in which your tropical cyclone causes destruction. And then, very important thing is that as it crosses the 30 degrees, it turns back towards the east. And then as it moves over the east, the 30 degrees, it will dissipate. In other words, it will die. Why will it die? Because there's no moisture, there's no warm air, and because of friction. Now, a very interesting thing with regard to your tropical cyclone is Madagascar that we have here. As you see, here we've got the tropical cyclone moving over Madagascar, and when it moves over land, then it usually starts to rain, and it can't pick up any moisture. And what happens is here, as it moves over Madagascar, then Madagascar actually protects Africa from tropical cyclones, because a lot of rain and a lot of the power is lost over Madagascar. So Madagascar, very important for Africa because it protects Africa from tropical cyclones. Now, this question was in the exams last year, right? This was the diagram that was given to the children, and these are the questions that they have asked. Now, let's have a look at this. You have to study the diagram and answer the questions that follow. Now, let's have a look at the questions. Some of them are very easy, and some of them are, you've got to think a little bit for some of these questions. The first one is that the question is, why is this found in the northern hemisphere? What evidence is here that this tropical cyclone is found in the northern hemisphere? Now, if you can remember when I started off with mid-latitude cyclone, I mentioned that mid-latitude cyclone was in the southern hemisphere. That's why we had the clockwise rotation of the winds. But have a look at this one. Remember that your tropical cyclone is also low pressure. Look at what's happening here. Anti-clockwise rotation. So anti-clockwise movement of your and rotation of your air. And that is why this is the evidence that this is in the northern hemisphere. Now, the second question. Why is the descending air in the eye dry? Here we've got the eye. Remember, if you can remember when I looked at the characteristics, remember what's happening at this question. All the characteristics that I've done in the previous slide should come back to you now, because most of them are here, the answers, supply the answers to these questions that we're doing now. Okay, so have a look at this. Why is the descending air in the eye dry? Can you remember we said the eye, no wind, no rain? Can you remember all those type of stuff? Right, so what we've got here, the reason why the air in the eye is dry is because the air does not condense. Condensation cannot does not occur in the eye. Right, now, here's an interesting question. Name the section of the moving cyclone where the highest wind speeds were recorded. Name the section of the moving cyclone where the highest wind speeds are recorded. I'll come back to that now. And the one where it says, explain the satellite images, I'll come to that as well now. I just want to quickly touch on question 5. Write a paragraph to outline the economic and environmental impact of tropical cyclones. Now, Matrixie, have a look at that question. I want you to read this question very clearly and understand it very clearly. Write a paragraph to outline the economic and environmental impact of tropical cyclones. Now, this question was quite well answered. Most candidates scored full marks in there. Where people lost marks was they only wrote of the economic or only environmental. Right? So please, people, remember, you must mention both. Now, this one is so easy. You can have a look at that yourself. Economic, how does, what happens there, environment, how the environment was destroyed by means of a tropical cyclone. Very, very easy. You can go to your textbook and have a look at this. As I said, this is a direct question. Now, have a look at this. I want to come to this one. Name the section of the moving cyclone where the highest wind speeds are recorded. Now, if you look at a tropical cyclone, the wind speeds aren't exactly the same everywhere. Now, let's have a look at the following. Here is the question that has been asked. Name the section where the highest wind speeds are recorded. Here we've got our tropical cyclone. Here's the eye, there's the low pressure. Okay, have a look at this. Here we've got 160 kilometers an hour, 140 kilometers an hour, and 80 kilometers an hour. Now, the question is, name the section where the highest wind speeds are recorded. Now, it's very important that you must know that the highest wind speeds, that section is called the dangerous semicircle. Now, this means that this part of the cyclone is the most dangerous part on the cyclone. Now, let's just have a look at this. Now, the reason therefore is the following, and now you must stay with me. Why do we get here 160 kilometers an hour, 140 kilometers an hour, 80 kilometers an hour? Why is the highest wind speed recorded in this section? Now you must stay with me, because remember in the exams they only asked last year that you must name the section where the highest wind speeds are recorded. That's easy, the dangerous semicircle. Now they can also ask you a higher order question. Why? Why do we get that this section of the tropical cyclone is very, very, very dangerous? This has to do with the following. I just extended these two arrows here. This is the direction in which the storm is moving. Remember, this is a northern hemisphere storm. And this, look at that, anti-clockwise, this would be my wind direction. Can you see that only in this area, the direction in which the cyclone is moving and the direction in which the wind is blowing is the same. Now I want you to understand this. Let's have a look what's happening here at this part, this half of the tropical cyclone. You must remember, this is the storm motion. In other words, this is the direction in which the storm is moving. Look at the direction in green here, in which the wind is blowing here. Do you see that's in the opposite direction? The storm is moving in that direction, and the wind is blowing in this direction. But in this semicircle, this is the motion. In other words, this is the direction in which the storm is moving, and this is the direction in which the wind is blowing. So that is very, very, very important that you must understand this. Okay, so name the section. You must know that's a dangerous semicircle, and see that after today that you really know why that semicircle, is much more dangerous than the rest of the tropical cyclone. Okay. Another question that was asked last year that you've also seen, that I showed you in the previous slide, is the following. Explain why satellite images are effective for tracking cyclones. Explain why satellite images are effective for tracking cyclones. Now, here we've got a beautiful photo. Here we've got a satellite flying over here, and there's the eye of the cyclone, right? And now the question is now, but why is this so why is satellite images so very, very important? Now, just have a look at this. Here we've got a tropical cyclone moving towards the coast of the USA. This is day 1, day 2, day 3, day 4, day 5, day 6, and so forth, up to day 7. So because they had satellite imagery, they could track the cyclone. They could see the path in which the cyclone was moving. They knew that this is going to cause destruction there. They knew it's going to miss there. It knew it's going to miss that part there. But this part of the US, that would be the area that the most destruction would be caused. Now, so what happens is, why it's so important, why satellite images are so important is the following. Firstly, the data you get is received in real time. That what you see is that happening at that very moment. All right? Then the data can be monitored every hour. Now that's very important, because with such a dangerous storm, you must be able to do that. Have a look at this. So, because they are monitoring the storm every hour, they will be able to plot a path of this cyclone, and they will be able to warn people to evacuate, or they will warn people to say, listen here, you are in trouble, this and this and this could happen. Okay. They could also determine the intensity of the storm by means of this satellite imagery. Then they could predict the path, as I've shown you here. Okay, and then a very interesting and very important one is that inaccessible areas can be monitored. So they can especially see and warn those people also when you've got the danger of a tropical cyclone approaching. Now, people, these tropical cyclones, I can ensure you that tropical cyclones are very, very important. Remember, you do 2 cyclones in your in grade 12. You do your mid-latitude cyclone and you do the tropical cyclones, okay? I've seen a few questions talking about the relationship between the two, and I've tried to explain it in that way, that you've got your mid-latitude cyclone, you've got your tropical cyclone, you must know what it's all about. Please don't mix up your facts when it comes to tropical cyclone and when it comes to mid-latitude cyclones. Remember, you do both of them. One of them, at least one of them, or both will be examined in the exams, okay? So you can't leave out any one of the two. Both of them were examined in last year's examination. And there's a 100% chance that you are going to get both of them in your June, your September, and the end of the year examination, because it's so very, very important. So people see that you know and understand everything with regard to the 2 cyclones that you do, your tropical cyclones and your mid-latitude cyclones. Okay, all right, let's move on. I'm going to have a look now at subtropical anticyclones and associated weather. And basically the things that I'm going to look at are the factors influencing the climate of South Africa, line thunderstorms, and the South African bergwind or bergwind conditions as they usually call it. Now, if you have a look at these 3 things that we've got here, I can promise you that you will not understand line thunderstorms and the South African bergwinds if you don't understand number 1 there, the factors that influence the climate of South Africa. Remember, we dealt with low pressure systems when we did the mid-latitude cyclone and the tropical cyclone. Now we're moving over to high pressure systems, okay? So that's why we've got here subtropical anticyclones, which is high pressures, and associated weather. Okay, so what we're going to have a look at now is the factors that influence the climate of South Africa. And as I've said, please people take note about this, that you can apply this to line thunderstorms and the South African bergwind. Okay, very quickly, let's have a look at the factors that influence the climate of South Africa. Right, firstly you must know the influence of the oceans. Now, Matrix, this you've learned from primary school level already. When we started working with atlases, there you learned that we've got the warm Mozambique and the cold Benguela. Right, so here we've got the warm Mozambique, here we've got the cold Benguela, and here as we just touch here on Eastern Cape and start to move towards Western Cape, it is called the warm Agulhas. So these are your what you must understand actually is that you've got warm water here on the eastern side of South Africa and cold water here on the western side of South Africa. And these two have a huge influence on the climate of South Africa. Hang on with that, we'll see what happens later on. The second thing that you must know, a warm and wet climate, and on this side, because you've got a warm water here, it will be warm and wet here, and on this side, it will be cold and dry. Now, okay, the second thing that you must know is your subtropical anticyclone. You must know where they are, you must know where they are located, and you must know the names. There are 3 of them influencing the climate of South Africa. The South Atlantic high pressure, the South Indian high pressure, and the Kalahari high pressure. The Kalahari high pressure is found in the interior, and obviously these 2 will be found in the oceans. Now, Matrix, you've got to take note about what I'm going to say now. Remember, there's no such thing as the Atlantic high pressure and the Indian high pressure. You are not going to get your mark, right? If they ask you to identify the high pressure at 1 or A or whatever, and it's in the Atlantic Ocean, the name is the South Atlantic high pressure. Please don't make a mistake and only say Atlantic high pressure. You're going to lose unnecessary marks. The same with regard to the South Indian high pressure, not the Indian high pressure, the South Indian high pressure. Please don't forget that. Okay, so let's have a look at this. So here we've got the Kalahari high pressure, and here we've got the South Atlantic and the South Indian high pressure. As we progress, you will see that the South Atlantic and the South Indian high pressure, they play a very, very important role when it comes to line thunderstorms, and your Kalahari high pressure plays a very important role when it comes to the SA berg wind or berg wind competition. So you must know the role of each of this. We'll have a look at this within the next few minutes. Okay, and the last thing that you must know with regard to the climate factors is the plateau or the interior, which is very high, and because it's high, the higher you go, of course, the colder it will get. Now, Matrix, if you have a look at these factors, now, okay, you must know these factors, but what's much more important is the application of these factors. You must be able to apply these factors. You must know how these stuff work. And if you know how these things work, it's going to be very easy for you to explain the berg wind conditions, and it's going to be very easy for you to explain line thunderstorms. Okay, so let's just have a look at this. Here we've got a wind map. And if you have a look at this, we've got a few interesting things come up. Look at this here. This is a high pressure system. Can you see the direction of the wind is anti-clockwise? So that's a high pressure. The name of that high pressure would be, that's right, that's the South Atlantic high pressure. Look at this here. Look at the wind moving around here. You see that is anti-clockwise. So what does this mean? This means that this here would be a high pressure. What's the name of it? This would be the, of course, the South Indian high pressure. Now, what's very important, as I've told you, is that we must know how do these things fit in when it comes to line thunderstorms and berg wind conditions. And if you have a look at this one, you will notice that this one is a summer one that we've got here. You see the lows here. We've got a low pressure in the other direction, very, very far to the south. Now, have a look at this, what's happening here. Here we've got the Atlantic. Now, you must see this. Atlantic, and look at the wind direction. There's the wind blowing, and it's over the cold Benguela. This is cold air, and can you see it's actually cold air moving in over the land on this side, on the western side of the country. See what's happening here. Here we've got the South Indian high pressure. This is warm water here. Can you remember the warm Mozambique? Here we've got warm air moving over, and it's coming over the land on this side, and we will expect that as the warm air moves, that we can get line thunderstorms there in the interior. So, when we have a look at line thunderstorms, exactly about a year ago we had this map of line thunderstorms here with us. And here we've got the cold Benguela, here we've got the warm Mozambique, and let's just see what happened here. Here we've got the South Indian high, here we've got the South Atlantic high, very important, south is written there. Okay, so our wind direction will be this. I'm just going to take it off again. Let's have a look at our wind direction here. Moving in, remember we said anti-clockwise. Follow the wind as it moves over the warm ocean, over the warm Mozambique towards South Africa. So what's happening is, that's happening, right? And what the result is that on that side of South Africa, we'll have warm and moist air. Right, let's see what happens here. Just remember the previous slide when these things were moving everything. So what's happening here? Exactly the same, but look at that. You see cold air? This is the cold Benguela, and here we've got cold air moving towards South Africa. Right, and here they cold and dry air, and they meet at the moisture front. Now, as they meet at the moisture front, that's your line. Okay, so you must know line thunderstorms, that's the line where they meet. It's a front. Okay, so what's happening now? Of course, we've got the warm air. The warm air moves over the cold air. The cold air actually supplies a kind of ramp for the warm air to move up. And what happens is condensation takes place, and you get your thunderstorms all along this line and towards the east of the moisture front. Why towards the east? Because our moist air is on this side, and our dry air is on that side. Okay, so this is your line thunderstorms. Matrix, please see that you are in a position to explain how line thunderstorms occur. It's very, very important. You must know, if you know the factors influencing the climate of South Africa, then if you know that, you will know how the high pressure works, as I've explained to you. You will know the names of the two high pressures involved here, which would be your ocean ones, the South Atlantic and the South Indian. You would know the one side warm air, the other side cold air. As it meets to each other, this happens, the warm air rises, line thunderstorms. It's as easy and simple as that. Then you must know how high pressures work, and you must know what to do and how to explain this. Very important skill for you. Okay, so these would be our line thunderstorms. This is just a synoptic weather map also of the same day, and you will see that here we've got the warm air coming from this high pressure here, and the cold air coming here from the Atlantic, South Atlantic high pressure, and that will have our line thunderstorms. We'll have on that side. So these are very important things, people, your line thunderstorms. Okay, now, remember we are dealing with high pressures at the moment. We had a look at low pressures, and we studied your mid-latitude cyclone, and we studied the tropical cyclone. Now we had a look at line thunderstorms. And we saw we're busy with high pressures, and by line thunderstorms, the most important high pressures were, right, your South Atlantic and the South Indian. I'm repeating this all the time because you must know which of these high pressure systems are involved. Now we're going to have a look at the South African berg wind. Yeah, I see somebody actually asked me, what is the South African berg winds and how do they occur and all those stuff. And here we're coming to the South African berg wind now. Now, okay, our berg wind conditions, very, very important. Now, I'm going back to this again. Remember, what did I say? I said that when we've got the South Atlantic and the South Indian, when they work together, you get line thunderstorms. Am I right? Okay. Now we're doing the South African berg wind. What is the high pressure involved there? The Kalahari high pressure. You must know that matrix. You must know which high pressures are involved by each of these stuff. Now, let's have a look. Here we've got our high pressure. Now, firstly, you must see this is South Africa here. Here we've got the mountains. That is why it's called the berg wind. Right? Berg in Afrikaans means mountain. Okay, so here we've got a high pressure. And what's happening, you should know now already, anti-clockwise southern hemisphere. Am I right? So here we've got it, high pressure in the interior. But the second thing that you must know is there's a low pressure over the sea. And you must know that wind blows from a high pressure towards a low pressure. Very important. Now, see what's happening now. Clockwise, anti-clockwise, circulation that we've got here. Here's it going. And what's happening now, I'm just going to have a look at this one wind here. Coming down there, see what's happening. As you've got your anti-clockwise circulation here, this air here descends down the mountains that we've got now. Now, the higher you go, the colder it gets. But when you go down, then it means it's going to get warmer and warmer and warmer. And that is why the air is heated. Now, what's happening now? As it gets heated, as it goes down here, these winds reach the coast here as a warm, dry wind. Very important that you must know that. And because it reaches the coast as a warm, dry wind, your big problem you've got here would be your veld fires that you find here. Now, this is what we got here, the South African berg wind. You know of it. The question is now, as these conditions prevail, how do they stop? When will it come actually to an end? It will come to an end when a cold front moves over an area. Let's just take our cold front back. Now, I want you to see the relationship between this and the mid-latitude cyclone. Now, those of you who can remember, you will know that here where I'm showing you now, there's your cold front, am I right? That would be warm air. Can you see all the warm air here, right? High pressure, warm, dry air here in front of the cold front. Remember that? We've done it with the first slide. Here behind the cold front, what kind of air will we get there? Of course, we'll get our old cold air. See what happens now. As the cold front moves over the area, it drags in cold air. And what the result is that all these conditions come to an end because the warm air is then being replaced by cold air. Line thunderstorms is a berg wind. People expect at least one of the two or both in the exams. Very, very important. Okay, so those are our berg wind conditions. I'm going to have a look now at valley climates. Very, very important. The effect of slope or aspect, inversions, frost pockets, and smog. Now, I am going to concentrate on inversions. As I've told you, there's no ways that we can do everything here. So, because we know we've got huge problems when it comes to inversions and how inversions work and the influence of those inversions. Those are the things that you must know. So, let's have a look at inversions. Now, this that I'm going to show you now is the basis of inversion. It's actually the basis of valley climates during the evening. Now, what we've got here is that we've got here katabatic winds and inversions. Now you remember this is happening during the night, right? Now, easy to remember, katabatic during the night. Cats walk during the night. Okay, here we go. So what happens is that the air has cooled off. And what happens when air cools off? It sinks down the valley slope. Have you got that? Look at our arrows here. The cold air sinks down the valley slope. Very, very important that you see that. Now, as it sinks down the valley slope, this warm air is being displaced upwards. Now, what's happening now? This means that here was warm air and here was cold air. But the cold air forced the warm air out. Now the warm air is on top and the cold air is at the bottom. But you know, you say, hang on. Isn't it that the higher I go, the colder you get? You're right. But we are dealing here with inversions. That is why. What is an inversion? An inversion is when the temperature increases with altitude. Let's just put it for you bluntly. The higher you go, the warmer it will get. Okay, so this means that here I'm going to get warm air instead of cold air because the cold air forced the warm air out. Okay, this means because it's so cold here at the bottom, I'm going to get a frost pocket there. I'm going to get smog there. And we are going to have huge problems for farmers because he won't be able to plant all his crops here. He will have to plant frost-resistant crops here. And those who are sensitive to crops, to frost, he will have to plant there. Now, this is the basis of valley climates. Now, during the day, just the opposite happens. What happens? Your valley is being heated, right? And what happens to the air? It rises up the slope, and then you get to anabatic effect. But these ones that we're talking about here, these ones are the ones that's usually tested because of the big influence it has on humans and their settlements. Okay, let's have a look now. Now, you must remember that this air, as it moves down the slope, then it means there was a high pressure on the slope, and here in the valley was a low pressure because winds or air always moves from a high pressure towards a low pressure. Now, this forms the basis of this exam question. And this exam question is very, very important. Last year, here's the question. Study the diagram on valley climates, and I must answer the questions that follow. Let's have a look at this. Name the wind 1 in sketch A. Here's sketch A, the wind 1. Right. Now remember, it can only be one of two, the katabatic or the anabatic one. So, that's it. So we've got the anabatic one here in the day, and the katabatic one during the night that we've got there. Okay. Now, the second question, state one difference between the winds 1 and 2. See, there's winds blowing there, and these winds 2 blowing there. Right, what's the difference between them? Here we've got it. Firstly, the one occurs during the day, this one, am I right? And this one occurs during the night. First difference. Second difference, what we've got here is that this one is occurs because of heating. In other words, it's warm air that rises. This one has to do with cold air that sinks. Another difference between the two. Another difference between the two would be that this one, wind blows from the valley upwards, and this one blows down the slope. Okay, so those are the differences between these winds that we've got. Now, here we've got, would wind 1 or 2 originate if a higher pressure occurred at the top of valley? Which one of these two would occur when the higher pressure is at the top of the valley? Remember what we have learned in grade 11. We have learned that winds always blow from a high pressure to a low pressure. Remember that. Okay. So the question says, where would wind 1 or 2 originate if a higher pressure was at the top of the valley slope? Now, let's have a look. Top of the valley. So this means, that's it. Winds always blow from a high pressure to a low pressure. Look at my arrows there. Okay? So that's very important. And the reason, therefore, is that the wind blows from the high pressure to the low pressure. Very important that you should know that. Okay. This one, actually the students didn't answer this one very well. Explain why visibility on the valley floor, this here at 3 at the bottom, is less on winter mornings. Draw a label diagram to support your answer. Remember what I said about diagrams? Very important. So, why is visibility less? Visibility is less because we've got a lot of smog and pollutants here. What's happening? This is happening. The cold air rolls down the valley. Here we've got it, right? And the inversion traps the smog here at the bottom, right? And the result is that you have poor visibility. Now, you had to, the matrix last year had to supply a diagram as well. Can you see where the diagrams come in, why it's so important? They would have got 2 marks for the direction, and they would have got 2 marks if they indicated the correct place where smog has been formed. Matrix, do you see why I'm saying your diagrams are so very, very important? Okay? So please practice your diagrams. These are easy marks, people, okay? And see that you really can gain the maximum marks when you write your exams or tests. Okay. I'm going to conclude with the last one, urban climates. Now, firstly, these are basically the 4 things that you've got there, the reasons for difference, causes of heat islands, pollution domes, effects of heat islands. These are basically the things that deal with urban climates. Now, what the basis of your urban climates, people, has to do with the following. The urban heat island effect. Now, what's the difference? Have a look at this. These are the urban areas and these are the suburban areas. Here we've got about 42 degrees. And here we've got it around about 30, 38, 39 degrees. So immediately you see that here we've got, it's much cooler here than there. Very important. And you must know the reasons why it's cooler there. Artificial surfaces, higher buildings, industries, many cars that you find there. All of these things cause higher temperatures. What you also must know is that this would be the heat island, right? What is a heat island? It's an area of high temperature surrounded by cooler, the rural area that's much cooler. In other words, your warmer city and your cooler rural areas. Look here, you've got 36, 34, 32, 33. See, the further you move from the city, the cooler it gets. Okay. Then you must also know your pollution dome. Your pollution dome is a mass of polluted air trapped by the inversion layer and prevented to rise. These are 2 concepts that you must know. Now, you have seen that here, they've asked a question, why is it warmer in the city than in the rural areas? Artificial surfaces, high buildings, industries, many cars, and so forth. Now, this is the question that has been asked last year. This exact diagram, I just added a little of color to it. Have a look at this. This is the CBD, 33.3 degrees Celsius, suburban, 31.29. The further you move, the colder it becomes. Okay, first one was quite easy. Calculate the difference between the temperature in the CBD and the rural area. All you had to do was to subtract that from that, and that would be 3.9 degrees Celsius. Now, the second question. Give the term that describes this difference in temperature. That, of course, would be your heat island. Okay, but now I want you to look at this question. Discuss how building density contributes to the CBD having higher temperatures. How building density contributes to the CBD having higher temperatures. Please, you couldn't write anything about your industries or the tar roads or all this. The question only dealt with buildings. Now, have a look at this. Here's the answer. Remember, it only has to do with buildings. The building density, the heat is trapped by the buildings, right? The heat is reflected between the buildings. And because the buildings are so close to each other, you've got a limited airflow to disperse the heat. So you see the heat is trapped. The heat cannot be escaped and is being absorbed by buildings. People look at this question. Many Matrix made the huge mistake by describing why the cities are warmer. This was not the question. The question only dealt here with building density. Please read your questions. Right, the last thing that I want to show you is that draw a label diagram showing the structure of the heat island during the day. Now, this is what it looked like. People, and this is very, very important. Here's the heat island. Remember, what is the heat island? Warm city, cooler rural areas. This is what it looked like. This is what the heat island is. You must know that during the day, it's much higher. 2 marks. And the air movement up, and then it goes to the left on that side and to the right. You must indicate the correct arrows. So that is what this would look like. And then, lastly, finally, give 2 sustainable solutions to reduce the temperature in city. Very high temperatures, there you can see it. Plant trees, roof gardens, commercial decentralization, industrial decentralization, tall chimneys, public transport, eco-friendly buildings. You can add still a few more solutions how to solve this problem. So, Matrix, that's it for our first lesson, our climate and weather lesson. Next time, we'll have a look at geomorphology. And thank you very much for being with us. We'll see each other next time. Bye-bye.